Now for our second episode of On the Edge of Change. In this series, we take you on board the research vessel SA Agulhas II. The ship is an icebreaker en route to the Antarctic, but also has students, lecturers and scientists on board. In today's episode, we learn more about how the currents affect our weather.
The Agulhas current is perhaps the fastest flowing current in the world.
It's a very special current.
It is an extraordinarily strong current.
We're in the middle of the fire.
So the ocean heat content has increased dramatically.
Everyone's now focusing on plastic and forgetting about bigger issues like climate change and human population growth and overfishing.
If we can stabilise, that would be a great start.
We are approaching the end of the age.
Humans survived the ice ages, and they probably will survive for many thousands of years more.
If we look at the average transport of the current, it is equivalent to 45,000 Olympic-sized swimming pools per second. So that is the water that is rushing below us right now. And that is just mind-blowing for me to imagine that.
It governs what happens on land, and people tend to think there's a disconnect between the ocean environment and terrestrial environment.
Now the Agulhas current transports warm, salty Indian Ocean water along the east coast of South Africa. And this warm water provides heat for evaporation. And so when winds blow over the Agulhas current, they carry this moisture inland, and so they control rainfall and have a big influence on climate over South Africa.
30% of all the rainfall that falls on South Africa's east coast is attributed to the Agulhas, right? So it has a huge impact on the weather and climate of our country.
We also have an Earth that is spinning. So what happens in an ocean basin, so let's use the Indian Ocean as an example, because you have Coriolis force, the spin, you have the currents moving to one side, and that creates a very fast, very strong current. So that flows from basically Mozambique. It brings with it the subtropical and tropical species. It's very warm, it's very salty, and it flows down along the coast of Durban and all the way to about Port Elizabeth.
It then does something called a retroflection, so it flips, it turns back on itself, and it returns into the Indian Ocean. And in this process, little chunks of Indian Ocean water break off.
Some of it will end up in the Atlantic and will become an important part of the heat distribution and salt distribution across the Atlantic Ocean. The Agulhas evidences very well this interlinked how interlinked we are. It's a current in the Indian Ocean, but it provides fundamental element for the Atlantic to function properly.
So what we are currently doing is we're sampling an area of the ocean called the ASCO Array, which is through the Agulhas current. This used to be an area occupied by what are called ocean moorings. So these are a series of instruments that go through the water column, and they measure the speed of the water passing by. So what we are doing now is we're going back to the location of those moorings, and we're doing CTDs. So CTD stands for conductivity, temperature and depth.
So what it is, it's a rosette that's got bottles all the way around, and about 24 bottles. And at the bottom of the rosette you have what's called an underwater unit, and that's pretty much the brains of the whole instrument. So that's where all your sensors sit. So it's attached to a cable. All the bottles are opened before you send the instrument down. We deploy it over the side. Most of them are rated to about 6,000 meters, so you can get a full profile worth of measurements as you send the CTD down. And the cable that the CTD is attached to is a communication cable. So it sends back real-time data of what the sensors are seeing.
Normally Agulhas current water is a combination of water masses that come from all over the world. You know, some of it comes from the Red Sea, sometimes carries Red Sea water, some of it comes through the Indonesian through flow. It sort of gives us an imprint as to where water is coming from, and long term you can look at it in terms of climate, any changes that takes place.
Climate change as an issue is of course a global problem, but local specific countries or specific regions within a country will experience climate change differently because of the local drivers of climate. So the Agulhas Current is one of the drivers of climate in South Africa, and part of the reason that we're interested in monitoring the current is to see if it's changing and see what's happening, because that will have consequences locally for South Africa.
So for many years, the Northern Hemisphere oceanographers and scientists focused their research on the Gulf Stream. Okay, so this is the current that flows along the east coast of North America. And this current transports warm water from the equator northwards, and that warm water is what leads to, for example, England and the ports of Norway to be ice-free, so much warmer conditions. Now, these scientists were concerned that with climate change and the melting of the Greenland ice cap, there would be an injection of ice, so fresh water, into the northern part of the Gulf Stream, and that would shut off the circulation in this area and therefore create a mini ice age in northern Europe and North America. So they put all their efforts into researching the Gulf Stream. Now, one scientist in America realized that the Gulf Stream actually gets a lot of its properties, specifically its salt properties, from the Agulhas Current. So this scientist in America, her name is Lisa Beale, she was my PhD supervisor, said, hang on, let's not focus all our efforts in the north, in the Gulf Stream, let's start researching the Agulhas Current. The South Africans then realized that there was this incredible groundbreaking research happening just off our coasts. And we said, well, hang on, we need to take ownership of the science happening just off our east coast. And so they started a collaboration with this American team. And that collaboration was called ASCA, the Agulhas System Climate Array. And that was put in place 4 years ago, and that was removed 1 year ago. And now South Africans are taking ownership of our research in this area, and now we are the ones doing groundbreaking research on the Agulhas Current.